Good evening. So I'm going to present the Redis use case in Moovit. First, I'm going to give a brief overview of what's Moovit, what we required and such. Build up the requirements that we have for Redis and the general requirements that we have and how we implement it with Redis. So Moovit is one of the leaders of public transportation. There are 8 billion people in the world, out of which 900 million have cars. The rest are potential Moovits. Currently, it's the world's #1 transit app, 35 million users, lots of languages, countries, cities throughout the world. Many, many, many users and transit operators. We expand very rapidly. We have a new city that we support every 20 hours, more or less. Now let's see how that translates into requirements. We have to support thousands of reads operations for users, which translates in read operations to database to tens or hundreds of Ks of operations per second. And we have to be extremely responsive. I mean, the 10 millisecond limit is quite a high limit for us. And as a startup, continuously delivering more and more functionality, this database is constantly changing, and hence, it should be quite easy to upgrade it. As I said, we have to scale horizontally and cover more and more geographic places, scale vertically, cover more and more users as they come tens of thousands of users every day. So that we call two-dimensional scaling. And we have to be bomb-proof. I mean, we don't want the database or anything to explode. So we need full redundancy, very extremely high availability, seamless failover, and no SPOF, no single point of failure. I mean, in our previous generation, we relied on a standard SQL database, and that's a SPOF. And data blocks. A data block is a metro area, is a city that we support. These data blocks frequently change holistically. I mean, the entire data can change entirely, and we can't have a situation in which the clients see partial data. So we need the ability to change these data blocks holistically. And for these switches, these data block switches to be fully automatic and manageable. I mean, we have many hundreds of metros, and we can't do this stuff manually. So now let's see how Redis provides the solution that accepts all these requirements. First of all, Redis is fast. I mean, thousands or 10,000s or hundreds of thousands of IOPS is peanuts for it. It's extremely fast. And regarding upgrades, there's no magic. I mean, you write the code. I mean, Redis is simple. You write the code, and the upgrades are as simple or complex as you write them. But that's better than a relational database that the upgrades can be a very, very big pain. That's up to here was Redis. Now, with Redis Labs, we wanted to better support stuff like the two-dimensional scaling. So we had the clustering that Redis Labs supported at the time. Currently, Redis also supports it, but back then it didn't yet. Full redundancy with high availability and seamless failover that Redis Labs gives. And in the end, very high availability. But still, this didn't support the holistic changing. I mean, once we had to change the entire data block, an entire metro data, that was a big pain since we had to write lots of data while users are still querying it. And that's when we went to this approach. We partnered with Redis Labs and we connected to their API, which allows us to create a database, to delete a database, to see what database there are in our subscription and such. And we have a Moovit loader, which manages everything. And at every given moment, we can simply switch an entire database of a metro or of a data block. And in this manner, instead of having many, a very big database with a lot of data, we have many small databases, hundreds of small databases containing each data block. So with this, we have no SPOF. Worst case, we have a failure in one metro. And we can replace the entire data holistically without interrupting reads. And of course, with the Redis Labs API, it's fully automatable, maintainable via the API. And of course, what Redis Labs gives is full resource utilization. I mean, if we had, for each of these databases, to have a separate EC2 instance, a separate machine, we would have to make a separate round just to finance that. Since Redis Labs, with Redis Labs, we care about the total size. It doesn't really matter if we had one gigantic database or many small ones. That's our solution. One thing regarding the high availability, I mean, I can't really say too much about that since we didn't have any failovers or crashes, so it still remains very theoretical, but it speaks about the stability. The big advantage of using Redis is that it's simple, as you previously saw. I mean, it's very simple sets and structures. 1 millisecond round trip that we have to access Redis is a very big overhead of what it does inside. And it's quick. And finally, it's also fast. And the things to consider when using Redis is, again, that it's simple. I mean, you have to write everything in order to make it work. I mean, it's not like a relational database that you have tabular data that you can query and such. And as I said, only simple structures. Everything else needs to be written. And that's me.